Hi, geometry students. Excuse me. Hi, geometry students. Welcome to your second digital learning day. What I want to do with this video is basically go over some problems that you saw from chapter 3. These are some big concepts that some of you guys may have struggled with, maybe you didn't, but they're the biggies that I want to make sure that you leave the unit understanding. So we have two lines here, and I want to say that these lines are parallel. Well, knowing that these lines are parallel, we've got three special pairs of angle relationships just from that. We know that corresponding angles are congruent, so if we can find them, we know that they have the same exact angle measure. We also know that same side interior angles are not congruent, they are supplementary. Again, that means that the two angles that are same side interior that we can find, they will add up to 180 degrees. And third, that alternate interior angles are also congruent, also have the same measure. So let's see if we can go ahead and find those things above. Let's go ahead and color code this. The corresponding angles will be black here. Let's just find a few here. We're not going to find everything in this picture because there are a lot. Matching up with this first angle, given that this angle is on the top of the bottom line, to the right of the transversal, well, look up here to the top line. You're looking in the same place. Top of the top line, to the right of that top line, you've got two angles that are congruent. Those corresponding angles are congruent. And there you go. Also, to the left of angle 1, we'll say 2 here. Given that it is above the bottom line, to the left of that knife cutting across your sandwich buns, we're going to look to the top line where the arrow is pointing. Angle 2 there is also corresponding. Those angles are congruent. That's important. Moving forward, this idea that parallel lines make special pairs of angles doesn't go anywhere. It's still going to stick around. I promise, I promise. All right, second one here. Same side interior angles are supplementary. Let's go ahead and mark that here with a 3. And given that we're talking about same side interior angles, well, on the same side of the transversal, that means we're on the right of the knife. In the interior of the sandwich buns, we'll put a 3 up there. You have same side interior angles. Notice that the bottom angle 3 is much smaller. It's less than 90, while the top angle 3 is bigger. It's obtuse. Small bottom 3 is acute. Big top 3 is obtuse. Together they are not congruent, they are supplementary. They add up to 180. Same thing to the left of this 2, we'll call this angle 4. Its pair would be with this angle bottom left on the top line. Again, the bottom 4 is obtuse, it's bigger than 90. The top 4 is acute, it's smaller than 90. They add up to 180. All right, lastly, let's look at 4 alternate interior angles, which are congruent. Alternate interior angles are going to be in the interior of the sandwich buns and the interior of the line on alternate sides of the transversal. Those could look like, looking at the bottom right here, 5, and right there. You've got alternate interior angles. They are congruent. They are both acute. If you were to rotate this angle around, it would perfectly overlap with this angle right here. They're the same measure. Same thing going on here. Number 6. Its pair is with the number 6 up here. Again, on alternate sides of the knife in the interior of the sandwich buns. Those relationships are important, guys. Do not forget them. I've got a homework assignment for you to attach to this bundle that is going to take advantage of that idea. All right, what I want to do here is first, I want you to notice how many sides each one of these polygons has. So let's count it up. One on the left here, we'll call this problem 1. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10? Or was it 11? I lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, okay. N is equal to 11. That's the number of sides. Well, some of you guys are really good at this. Some, of course, are not. And that's why we're talking about it. To find the sum of the angles inside this polygon, all you need to know is the number of sides. You've got a couple of things you could do. You could draw lots of triangles all across, starting from the same vertex, count up the sum of the angles, or some of the triangles, but that's actually harder then using what's on your reference sheet, the n minus 2 times 180. What this does right here is it finds the sum of all those interior angles of the polygon. So if you know n is equal to 11, you're just going to plug that in right here. So we're going to say 11 minus 2 times 180 degrees, which is 9 times 180 degrees. Let's see. I think that comes out to be 1620. Let me double check my math. Yes, 1620 degrees in the interior of that polygon. So let's try this one more time. Let's do this in blue. Let's first count the number of sides. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. Let me double check. 2, 4, 6, 8. I think so. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 10. Okay. Man, it's easy to lose track. N equals 10. So we'll just plug the 10 into the n minus 2 times 180 degrees right here. So we have 10 minus 2 times 180 degrees, which is 8 times 180 degrees, or what would that be? 1440 degrees. No big deal. And there you go. There you go. That's an important idea. We're going to return to that semester too, regardless of whether or not you stay in my geometry class next semester, in the fall semester. You will see that again, I promise. All right, last slide I want to look at here. I want to look at two different triangles. We're going to do two different things with these triangles. First triangle, I'm going to make up some angles here. We've got x plus 17, we've got 53, and we've got, we'll call this 39 degrees. And let's say I want to solve for x. Well, whenever you have a triangle, you know that the sum of these three angles here they are supplementary. They add up to 180. We can use that every time to solve for the remaining angle that we don't know about in a triangle. So we'll say 39 degrees plus 53 degrees plus x plus 17 degrees equals 180 degrees. And solve that for x by combining. So you get 109 plus x equals 180 degrees. Subtract off the 109, x is equal to 71 degrees. And there you go. Not too bad. All right, in blue here, let's go ahead and try one more here. We've got, let's call this y plus 3. This will be y minus 40. And this will be 35, something like that. Okay, and let's solve for y. Well, notice this angle here is an exterior angle to the triangle. It's formed by this line from the triangle that extends beyond the triangle. That means that it's actually, this exterior angle that I circled is the sum of these two boxed angles. So we can say y plus 3 equals 35 plus y minus 40 and solve for y. So we have y plus 3 equals the 35 and the negative 40 on the right give you negative 5 plus y. And let's make this a... we're going to change this to a 2y. 2y. We're changing the problem so it makes a little bit more sense. All right, let's subtract 2y from both sides. So we have negative y plus 3 equals negative 5. Subtract off the 3 from both sides, you get negative y equals negative 8. Divide by negative 1, and y is equal to 8 degrees. And there you go. All right. I will have posted in this bundle, you will see a homework set that I've got for you guys. Make sure that you do that for Monday next time I see you. Have a lovely weekend, and I will talk to you later.